As you can imagine, it's pretty difficult for a computer to send out all those samples exactly in time to reproduce the audio in the digital to analog conversion process when we're outputting to the speakers. The computer has to be incredibly accurate, right? Every 44,100th of a second, it has to send out two 16-bit words perfectly in timed over and over and over. It's actually quite a complex task. Luckily, our computers can process billions of things per second, so it seems like it wouldn't be that big a deal, but the computer processor is actually doing many other things at the same time. It's, putting graphics on the screen, checking your email, looking to the internet port, getting audio from something else, processing reverb and compression. It's doing a lot of things at once. So what it needs to do is collect kind of a queue of samples that it can be ready to throw out to the digital to analog converter at any point. And that way it can fill that queue with some samples, go check the graphics, go back to that queue and throw some more samples out to the D-to-A converter. And that queue, that kind of buffer of samples is called the buffer. And one of the things you're going to have to set up, and no matter what DAW you're dealing with, is the buffer size, how large that audio buffer is. And it's a necessary thing, but it does provide kind of a trade-off in that if you have a larger buffer size, you'll be able to use more plugins, more software synthesizers, and the computer can kind of run a little more efficiently. But there'll be a delay when you're recording. And that's a really big concern. We talked earlier about the need to use a direct box and an amplifier when recording bass or guitar, just because of this delay. There'll always be a delay when you're monitoring or listening through the computer because there has to be that buffer. So setting that buffer becomes a really important thing and something you're always going to do, and you're going to have to be very aware of it. And the general concept is that the lower the buffer size, the less the latency or the less the delay, but also the less plugins and instruments you can use. The higher the buffer size, the more the latency and the less plugins you can use. So what we tend to say is during the production, the recording or the tracking of the instruments, we like to have the buffer size quite low. And I would say for a low end, around 128 samples is fine. And then during the mixing and editing process, you can turn that up quite a bit, maybe to 1024. You notice these numbers? They sound familiar, don't they? In that they are perfect powers of 2, right? 128 is 2 to the 7th power. 1024 is 2 to the 10th power. So we see that these numbers show up in more places than the digital audio properties. We're going to see these kind of powers of 2 all over the place. You can kind of think of it as the computer having only 2 fingers and having to do powers of that. Like we have everything based on powers of 10. There's no real reason for that except that we have 10 fingers. Well, the computer has 2 fingers. So everything is based on powers of 2. So again, to recap, you're always going to have to set your buffer size. And you're going to set it low, around 128 when recording, which we also call tracking. And then you're going to set it higher when editing and mixing. And you don't have to just turn it up right when you start editing and mixing. You'll just wait until the computer starts complaining. Eventually, it'll kind of start glitching and kind of not be able to compute that audio in time. You'll get errors, and it'll just kind of have trouble. And once you get to that point, that's when you start increasing the buffer size. Now, you will encounter problems with this that are not easy to fix. And one of the most common ones is what happens when you've brought in all software instruments and you have all these effects, but you need to record something more. So you have this issue where you have a high buffer size because you have all these plugins, but you need to record something else, and you have this latency you're dealing with. The solution there is nearly always to record things down to audio. You want to remember that the computer has trouble processing plugins and soft synths in real time. So if you can reduce the number of plugins and soft synths you're actually processing through, you'll be able to reduce that buffer size. So if you have lots of tracks that are running at once, if you can record them down to audio and then play back just the recorded audio, you can then bring down the buffer size. There are many features in a DAW to do this automatically. Things called freezing, or freezing a track, is just that process. The computer records the track to audio, which it plays back in the background. You hardly notice that it's happening, but it reduces the CPU strain dramatically, and then you can use a low buffer size. I would like to relate buffer size to the principles of digital audio. And remember that the buffer size is a collection of individual samples, and the amount of delay it imposes will be related to your sampling rate. If I have a sampling rate of 48,000 hertz, that means I have 48,000 samples per second. And then I have a buffer size of 128 samples, that's going to give me a delay of 0.002 seconds or 2 milliseconds. That's a tiny delay and will not be noticed by the player, so that's fine to record through and a fine setting to have when you're recording. If I have a buffer size set to 1024 though, that's going to give me a delay of 21.3 milliseconds, which will absolutely be noticed by the player and will be hard to really groove with that kind of delay. Now, so we want to record the low buffer size, and we find that software companies are always at the edge of what computers are capable of. So to record at a low buffer size with the sufficient plugins, it's really going to require that you have a high quality computer with high CPU speed and sufficient RAM. So really consider, if you're going to work with music production, you're going to need a very high quality computer, or you're going to have to really pay attention to these preferences and be adjusting them as you go through the production process.